disk of the larger black hole. And because here it only lasts for 1 day, it must have been the smaller black hole and not the larger one. Mostly because the effects around the larger black hole usually last much longer. And at the same time, NASA Fermi telescope was able to observe this as well and detected the biggest gamma ray flare coming from this region. And this suggested that the secondary jet from that secondary black hole was possibly interacting with all of the gas around it, producing some of these very powerful gamma rays. But I guess some of the most studies and some of the most important discoveries were all made in early 2025. We now have very specific and extremely precise simulations showing us exactly what's happening in the system and showing us how everything seems to work. And these beautiful simulations are right now extremely accurate. Basically here it combines physics of gravity, fluid dynamics, and electromagnetism to rigorously test the binary model. And so far, every single prediction from this model seems to match what we observe in real life, basically confirming that the idea being that there is a collision of a smaller black hole in the accretion disk that happens twice, with the disk then generating enough power to account for every single bright flash. But because these simulations go a little bit further, here they also make some really intriguing predictions. In this case, it shows that the repeated impacts seem to dramatically modify the accretion disk with the gravity of the orbiting black hole, making the disk tilt and also warping it quite a lot. So this simulation the tilt can be quite dramatic, anywhere from 10 to 20 degrees, with these collisions also generating a lot of internal spiral shocks, which, as they fall inward, temporarily boost the rate at which the once again. And so right now, these very detailed models provide us with a crucial, fact-based visualization, and basically explain pretty much everything in the system after 150 years. But I guess the question here is, okay, so why exactly does this matter, and why is it so important to modern astrophysics? Well, this represents the best possible example and the best possible laboratory we have for studying these supermassive black holes, and specifically binary black holes that we actually don't really see that much. And so here, because of all these very precise emissions, we can now study everything from the accretion disk to the jet, and can obviously use this to confirm various ideas and various propositions, including various Einsteinian principles, or anything else in regards to additional theories such as quantum gravity. Moreover, this is a great test for additional technologies, such as trying to observe black holes super far away. And the fact that scientists were able to see a tiny part of the jet super close to the black hole is already pretty impressive. At the same time, this is also an important exploration that helps us understand how black holes grow and what happens when large galaxies collide. Since we think galaxies grow through mergers, this also means that central black holes have to either collide or possibly replace one another, with one of the black holes getting kicked out. And so in this case, OJ287 gives us a direct observation of what seems to happen at these final stages. This actually relates to a really important problem known as the final parsec problem that still doesn't have a very good answer. You can learn about this in one of the videos in the description. And so here, based on all the calculations, we're pretty certain that these black holes are also going to merge, but probably in about 10,000 years. But as they move closer and closer together, they're also going to be producing even more emissions and even more gravitational waves, suggesting that the emissions from this object are going to become more and more extreme. Now, right now, we don't have the technology to detect these gravitational waves yet, but by using what's known as the pulsar timing array that has been used in the Milky Way galaxy recently, once again, the video in the description talks about this a little bit more, scientists might be able to spot some of these passing gravitational waves and reproduce massive tsunamis in nanohertz frequency range, accurately tracking and predicting waves. Astronomers gain crucial data needed to improve our models of gravity and basically help us understand what happens in these absolutely ridiculous experiments. And so here, OJ287 is not just some kind of a distant, bright point of light. This is a very important physical confirmation for a lot of different astrophysical theories we have today. As a matter of fact, so far it's been able to confirm most of the cosmological principles. And so if we do actually see something somewhat bizarre in this system and cannot explain it, it's only in that case that we might have to start reworking some of the theories. For now though, all of the observations seem to match the theoretical predictions. But obviously, because this is science, the research is still going to continue because scientists do want to find something even more bizarre, or possibly something that will be kind of difficult to explain. And so here are the
Nature's Bounty supplements your gut and immune health with 20 billion live probiotic cultures.